All right, in this video, this is the highlights from the live session number 10 that I did over in my Facebook group in April of 2021. It was actually April 1st. We did 4 random examples that you can see here on the screen. We also did a giveaway where 5 people did win a copy of my TEAS Math workbook as well as the multiple choice review. And in this live session, we had almost 150 people attending. It's fantastic. So without further ado, let's go ahead and look at the highlights from that live session. So this is one of those updates that I just added to my workbook, and I also have some links over here where you can go and see videos for problems similar to this. Now, for this particular problem, what I'm going to do and the way I teach it, I do not teach FOIL method because FOIL method does not work with this problem. If you don't know what FOIL method is, then don't worry about it because I promise you it will not work with this problem. I'm going to highlight the individual pieces or parts or terms is the technical name. I have that 2x. I have this -5. I know you see a -5, but I'm going to think of it as a -5 because we're going to be multiplying these things right here in a moment. Then over here, I see a 7x squared. We also see a positive 4x. And then we also see this -3. Again, I'm looking at those signs because we will be multiplying. Now, what we want to do, I'm going to distribute every term or every piece in this parentheses to every piece in the other parentheses. So if I distribute, boom, boom, distributive property. If we take 2x times 7x squared, we can multiply our numbers together first. So 2 times 7 is going to give us 14. And we have this x here. And we don't see an exponent, and that kind of confuses people sometimes. It's an understood one. X is the same thing as x to the first. But since we're multiplying here, there is this rule that you have to add your exponents when you're multiplying terms. That is the rule. If I take this x times x squared, that is going to be x cubed. So that's the first piece I got from this distributive property. Well, let's keep on distributing. Take this 2x, multiply by this 4x. So 2x times 4x, well, 2 times 4, they're both positive. That's a positive 8. And remember, x to the first times another x to the first, that's going to be x squared. Now, we have to distribute one more time for this 2x. 2x times a -3. 2 times -3, watch your signs, is a -6. And what people forget is they see this -3 and they forget that this was a 2x. You got to keep that x here along for the right as well. So I've distributed 3 times. 3 times. Now let's come and do the same thing with the -5. So -5 times 7x squared. -5 times 7 is a -35. Watch your signs. And even though we don't have any x's here, we do have x squared. So bring it on along for that piece there. And I do see some answers coming in. A is the correct answer. And now we're about to get to that point right here momentarily. So this -5 times this positive 4. -5 times a positive 4 is a -20. Don't forget your x because the 4 had one with it. And then last but not least, one more time, we have to distribute this -5 times this -3. And a negative times a negative is a positive, and we get 15. So I know this looks crazy. That's why I've included so many examples in my workbook because it's repetition. And once you do this, it makes things a lot, you can just go through it a lot faster. So right here, we're not done because we have to do something called combining like terms. And that's something that people kind of struggle with because we were just adding exponents. So combine like terms. That's what we're going to do in this step right here. Sure, I was changing the exponents when I was multiplying these terms. I took that 1 plus that 2, I got that 3. And now that we're done with that, we want to come in here and look for like terms. And what is a like term? If we look at this x cubed term, I don't see any more x's getting raised to the third power. No more up here. So I'm going to bring that down as part of my answer. Moving on to the next one. Let me just change a color here. So I see a 8x squared and I see a negative 35x squared. Now I know that says, or you may think minus 35. Well, good news. If you have at least one positive number and you're trying to add or subtract, let me just load up a calculator here, basic calculator. 8 minus 35 is going to be a negative number. Oh, and I see I said positive and I wrote a negative. Boom. So let me fix that. Sorry about that. So that is a positive 15. But back to this combining like terms. 8 minus 35, that's going to be a negative number. So 8 minus 35 gives us a negative 27. That's going to be negative 27x squared. We're combining like terms there. So 8 minus 35, negative 27x squared. And then let's do the same thing for these other pieces. So minus 6x minus 20x, that's a negative 26x. And really what I did there, folks, if you think of what's 6 plus 20, we probably would all say, oh, well, that's 26. Well, what you probably never thought about is that this 6 is positive, this 20 is positive. When your signs are alike, like a positive 6 and a positive 20, you add them and keep that same sign. So if I take negative 6, which is what this one is, and minus 20, well, this 6 is negative. This 20 has a minus in front of it. So when these signs are alike, we want to add these numbers and we want to keep the sign. The same rule applies to what you've been doing all your life. A positive 6 plus a 20 is positive 26. Well, a negative 6 minus 20 is a negative 26. And then back to the plus 15, that was definitely a plus. So thanks for bringing that to my attention. And the only one that matches is going to be choice A. And I see that flying in a lot, so that's good. So that's number one. Switching gears a little bit, this is number 2. Now, this is something similar. If y'all have attended those mini sessions where I meet with 10 students or less, I have changed the numbers up. But this is not a problem I would do a proportion with. I know proportions are popular, but sometimes, people are like, oh, I'm going to do a proportion for every problem. And that you can't do that, unfortunately. And this is an example of where I would not use a proportion, though you could. Watch how I'm going to do this. So Jackson, that's my son. He is lining up Matchbox cars. He loves to do that. So we got Matchbox cars. And if I get my pen, so imagine these beautiful ovals are Matchbox cars and we're lining them up to make like a train of them. Each one of these cars is 2.5 inches, or we can think of it as 2.5 inches. And the line of cars measures a total of 2.75 feet. It's throwing up a red flag. Inches and feet. So we got 2 different units of measurement going on. So if each car is 2.5 inches long and the total length of all of the cars lined up measures 2.75 feet, approximately how many cars are in the line? So now that I've mentioned that to y'all, 2.5 inches is a little bit shorter than probably your index finger. 2.5 inches. Probably, about maybe 2 of your knuckles and halfway, but let's just say your index finger. That's about the length of a Matchbox car. Well, we would have to have a whole bunch of our index fingers or these Matchbox cars to form a line that is over 2 feet long. So watch what I'm going to do here. I'm actually going to convert my feet, 2.75. A way that you can convert feet to inches is to multiply by 12. Period. End of story. 2.75 feet, if you multiply by 12, because there's 12 inches in a foot, let's do that. 2.75 times 12, we get 33. 33 inches is the number of inches in 2.75 feet. So the 33 represents the number of inches. And I did this because now that's telling me that this train of cars is 33 inches long. Well, it's going to take quite a few of these 2.5-inch cars to make this train that's 33 inches long. Well, and what we can do, I do see a comment, can we divide? Take the 33 total inches and divide it up into how long one car is, 2.5. And if we do that, it says approximately, so this is an indicator that we're probably going to round. Take my 33, that's the total length of the Matchbox cars lined up, and we're going to break it up into how long each Matchbox car is. So divide by 2.5, and we get right around 13. So this says 13.2. Obviously, we cannot have 0.2 cars. We would just say 13. And our answer there is B, and I do see that coming in on the chat. That's fantastic. But so totally different problem than the first one. And now we're going to switch gears yet again. We have an absolute value graph. So graph the following inequality. The absolute value of X is less than 4. That's how we read that. Let me go ahead and type that up there so we don't forget that. Well, actually, you're going to hear me say it in the video, but anyway, the absolute value of X is less than 4. That's how we read that in English. Now, what does absolute value mean? So, I'm just going to write down some numbers over here. I'm going to say the absolute value of 5, absolute value of -5, absolute value of 3, absolute value of -3, absolute value of 10. I'm just doing some random numbers, y'all. You'll see where I'm going with this right here in a second. Absolute value of 2, and let's do one more. I just want to go ahead and drill this absolute value right, and let's do one more. What did I say? Let's do -1. So absolute value of -1. When you take the absolute value of something, it's always going to be positive, period. So, first one, absolute value of 5 is 5. Absolute value of -5 is 5. The answer's always positive. And really, the definition of absolute value is how far is that number from 0? How far is that number from 0? And you might say, well, what does that mean? Well, -5, even though the number is negative, -5 is still 5 units from 0. It's kind of like when you travel. I mean, if for some weird reason, if you were to get in your car and travel backwards in reverse, you're not going a negative distance. I mean, you're going in reverse, but your distance is still going to be a positive number. So think about it like that. Anytime you take the absolute value of a number, I don't care if that number is positive or negative on the inside, its absolute value is always positive. So what I want to do here, I'm curious, out of all of these random numbers that I've made up, which one of these or which of these are less than 4? Which of these are less than 4? So paying attention there. Let's see. Well, this one's not because that's 5. 5 is not less than 4. Same thing here. This one works because the absolute value of 3 is 3. Well, 3 is less than 4. This one right here works. This one right here does not work. The absolute value of 10 is 10. Well, 10 is not less than 4. Absolute value of 2 is 2. And the absolute value of -1 is 1. So all of these values are just a few of a bunch. Now, what I want y'all to notice is these ones that I've circled, we're looking for those to be shaded on our graph. Shaded. So if we look at like 3 and -3 and 2 and -1, so we're talking about numbers that are going to be in between -4 and 4. But notice none of those are highlighted or shaded for answer A. That is not our answer. Same thing for this one. You know, all of these numbers, like 3, -3, 2, and -1, none of those are shaded. So we see a very similar thing between C and D. And that's what I haven't talked about yet. What is the difference between coloring the number in or shading it in versus an open circle? If you see a greater than or less than, it's going to be open. If you see a greater than or equal to or a less than or equal to, that is when we close that thing in. So if we go back to our problem, make this, hopefully y'all can see that. That should be all right. Less than 4, I don't see the little equal to symbol. So I want to leave my circle open, which means D has to be the answer. And that's the only difference between C and D. But y'all, let's make sure we understand this. All of these numbers, 3, -3, 2, -1, notice those numbers. -3, there's our 3, here's our 2, here's our -1. All of these numbers lie in that shaded region. And we're only using open circles because we don't have the equal to symbol up there. I talk about this, I'll include a link, but I have an absolute value series where I dive into this in detail. Like, there is actually a way you can look at this and determine, are we going to connect them or are we going to spread them apart? What I'll do is I'll include a link in the notes. Just remind yourself, just hang tight. I can find it. It won't take me but a few seconds. I'm going to copy this link over into the notes, but I just want to show y'all. In this video, I dive in detail about when do we shade away from the values versus when do we connect them, so to speak. And I'm using some of the same stuff that I was talking about tonight. Not only that, in this video, you can see we have a greater than. That's our open circles. We have a less than or equal to. Notice I closed my circles. So let me go ahead and copy that. And I'm going to throw it into the notes. And I'll tell you what, I'll also pop it over in the comments if y'all want to go ahead and maybe load that up. Don't watch it now. Keep on listening to me, but save it for later. And now this last one. So I posted this mnemonic a while back. I did not come up with this, so I don't take credit for it. I found it online. But y'all, if you can remember this mnemonic, kind of like PEMDAS, please excuse my dear Aunt Sally, or King Henry drinks Ucky Dark chocolate milk. Some of y'all may say King Henry died by drinking chocolate milk. This is just another one to remember, but watch this. So these are our Roman numerals. I value xylophones like cows do milk. Okay, maybe y'all have already seen that, but here, so notice the first letter matches our Roman numeral. And you're like, okay, I got that, but now I got to remember all these daggone numbers. Check this out. There is a pattern. If you can remember I value xylophones like cows do milk, you can probably write this down in about 5 seconds on the TEAS test if you run across a Roman numeral problem. Watch what I'm going to do. Notice the leftmost digit is either a 1 or a 5, and we have an alternating pattern. So I'm going to do 1, 5, 1, 5, 1, 5, 1. Not only that, I want you to notice the first two, the I and the V, they do not have a 0. So I'm not going to add zeros to these first two. But then the next two have 1 0. So we got a 10 and we got a 50. Oh, look at here. The next two have 2 zeros. So 2 zeros, 2 zeros. And then our last one, the M, we have 3 zeros, 4,000. Boom. It's got a pattern to it. 1, 5, 1, 5, 1, or how many ever. And then notice the zeros. No zeros for the first two. 1 0 for that second group there, followed by 2 zeros for those, and then 3 zeros there. Now, with that said, how do we do Roman numerals? What you don't want to do is you don't want to jump the gun and just automatically add everything up. And I already see some answers coming in. What I'm going to do is I'm going to write down what each one of these represents. I'm just going to do like this. So we got a 100. We have a M, which represents 1,000. We have a L, which represents 50. X is 10. We got 3 of these, so I'm going to write all those down. And then we have this I, which is a 1, and then this V, which is a 5. Do not add automatically. Listen to what I'm about to say, and I also have some videos on this as well, but I think this is going to hit home. What you want to do, look from left to right. Look from left to right, and if you ever see a small number come before a bigger number, like right there, I have a smaller number coming before a bigger number, and I'm talking about going from left to right. Well, if you see that, you must subtract. So I'm going to take 1,000 minus 100. This gives me 900. We do not add those. And again, it's because you have a smaller coming before a bigger. Okay, so we're done with that spot. Now, I don't see a smaller in front of a bigger here because 50 is bigger than 10. And in these 10s, I don't see it. But whoa, check it out. Here it is again. We have a smaller in front of a bigger. We do the same thing we did back here. We take 5 minus 1, take the big one minus the small one, and this gives us a 4. Now what you can do is you can come and add everything up now. So let's see what we got. We got 950, 960, 970, 980, 984. That is our Roman numeral. Now, if we did not have this junk going on here where we have a smaller in front of a bigger, if we did not have that, then you would just straight up add. For example, just to kind of end on this before we do the giveaway, if I did L, X, and an I, all right, just make sure we understand this. L, 50, X, 10, I, 1. Notice, we do not have a smaller occurring in front of a bigger, so since we don't have that, we just add these up. 50, 61, done deal. You only do the subtraction when you have a smaller occurring in front of a bigger. So I hope that helps. We have over 130 people. I love it. Thank you all so much. This is the closest thing I have to being in a classroom. So I am excited to see that there's so many people here, eager to learn, eager to put this test behind them. And I'm glad y'all are putting your trust in me to help you do that. So, giveaway time. So copy and paste those names into here and we're going to go. So 5 random winners. All right. Well, y'all, thank you all so much for tuning in. Look for the video sometime in the upcoming days. Have a happy Easter, and I will talk to y'all in the group. Good night.